All right, continuing on with our questions here. We've got the back side of the sheet, and it starts off with a graduated cylinder has a water level of 20 milliliters, is where we're starting off with. When an object is dropped in the cylinder, the water level rises to 25.6 milliliters. Well, let's look see what's happening here. You see this a lot on density problems where I've got a graduated cylinder. I'm going to draw this for you. And it's saying the water level was at 20 milliliters here, so I'm going to write 20 ml. And then when an object is dropped in the cylinder, the water rises to 25.6. So after we drop it in there, it pushes the water out of the way, and the water level actually rises up to 25.6 milliliters. The reason why they give us that information is because we need to find the volume of that rock, and this is the displacement method. The volume of the rock is not 20 milliliters. That was the volume of the water that we started off with. And it's not 25.6. That's where the water level ended up. The displacement of the rock that we dropped in the water equals to how much did it move that water? How much did it push it up? So the difference between these two values, so again, it's not 20 milliliters, it's not 25.6, it is 25.6 minus 20. And of course that leaves us with 5.6. We're going to use centimeters cubed here because we're talking about a solid rock or a solid object. But remember, a centimeter cube is the exact same thing as a milliliter. So all we did was we look at where our water level started at. After we dropped the object or the rock in there, I'm assuming, how much did that water rise? That's what we're looking for, the difference between where it started, and we use subtraction for that. So 25.6, where we ended up, we subtract what we started with, 20, and that tells us how much did that water rise, and therefore what the volume of the object itself is. So we have down here, let's write it down, volume equals 5.6 centimeters cubed. We have the mass here is 120.4 grams, so let's write it down, mass equals 120.4 grams. And we want to know the density of that object. And it says, hence, find the volume of the object first. Well, that's what we already did. That's what we already did. Find the volume of the object first. That's what we did up here. So to find density, our equation is density equals mass divided by volume. Let's draw another circle over here that we can always come back to on this page, where I've got mountains up top, Death Valley down below. If I'm looking for density, because it says calculate the density of the object, if I cover up the D, because you cover up the one you're looking for, density, that leaves me with mass over top of volume. So it's, what do we have here? Mass divided by volume. And then we just plug in our numbers we got. We have mass is 120.4 grams. Volume is 5.6 centimeters cubed. Take our calculator. 120.4 divided by 5.6. That leaves us with 21.5. Again, there's our units right there. Grams over top of centimeters cubed. And then number 9 says, what is that object? That's up here in number 8. Well, of all the numbers we're looking for density. And in this case, that was the answer we got. Calculate the density of the object. That's what we got right here, is the density of the object. So using our sheet over here, 21.5 grams, that's going to be platinum. So platinum would have been the answer to that one.